All right, so what are we gonna do today is we finish the practice session for chapter 4. Okay, we have around 7 questions. Okay. Before we do that, let's discuss the schedule for the next several weeks. The first quiz number 1, okay, which will be on March 23rd. Okay. That's the Tuesday after the spring break. Okay. Quiz number 1 will serve as a practice for our midterm. For this class, we only have 1 midterm. Okay. Okay. So quiz number 1 again is the practice for the midterm, March 23rd during the class time. So 2 o'clock, Tuesday, March 23rd. We do that on the Connect website. Same thing as you do on for the homework. Okay. So that is quiz. For the midterm, I think we do that on early April. I put it on April 1st, which is a Thursday. Okay, so if you are all okay, let's make this time for our midterm, April 1st during class. Midterm will cover from chapter 1 to chapter 4. Yeah, basically the same format as our homework. Okay. We'll talk more about the midterm in the coming weeks, or the week after the spring break. But any questions for the quiz and midterm before we start today's class?
Yes, I have some questions. Is quiz 1 review material basically what is in our homework assignments?
It is pretty much similar to our homework assignments. Okay.
Is there any specific review material that you can recommend?
Oh, all right. So if you do the homework number 1, homework number 2, by the way, the homework number 2 is due on the March 23rd. So you better finish that before the quiz number 1. Okay. And also, you can review our practice session during the class. We have chapter 1, chapter 2. And we have maybe 2 or 3 classes on that. We review the video for the lecture. And also, chapter 3 and chapter 4, we have 3 classes reviewing practice sessions for questions from chapter 3 and 4. Okay. So do that before the quiz and midterm. And I think you should be fine.
Okay. Thank you.
Thank you. Any other questions? Okay, let me know. We have 7 questions remaining for chapter 4. The first one is 252 page number 2. Okay. So this is the finding the areas under the normal curve. Okay. We use table 8.2, which is also called Z table, to calculate the probability.
Traditionally produced a lot of very good NFL players. Last in 2019,
Could you mute yourself? I hear somebody talking. Okay. Good. All right. So find the area under the normal curve. Part A is to the left of Z, 0.56. Okay. Right. Again, refer table 8.2. Which is yeah. Okay. So table 8.2 is cumulative normal distribution, or the Z table. Okay. So we have do question using the Z table many times. To the areas to the left of 0.56. Okay. Say 0.56. Sorry. the table again. So 2.56 is here, Z is 0.5, 6 is here. Okay, right, 0.7123. Remember, the areas or the probability is to the left hand tail to the Z value. Okay, so part A is 0.7123. B is between two values, minus 2.93 and minus 2.06. Okay. Minus 2.93 and minus 2.06 for these two values. So minus 2.93, 2.9 is here, 2.93 here. Okay. So 0.0017. 0.0017. Okay. So that's the areas, this part on the left-hand tail of 2.93. Okay. And then for the other number, minus 2.06. 2.06 is here, right? So it's 0.0197. Okay, so we should use 0.0197, okay, which is this area minus 0.0017. Okay, so that's the area between these two values. Okay, because that's the question asked. Okay, so that's why we should use this. Okay, so that's part B. Part C is also between two values. Okay. So if you save me some time to go back and forth between page 253 and table 8.2, just tell you part C is asking between Z of minus 1.08 and positive 0.7. Okay, so again, this is between two values, we do the same thing. Minus 1.08, positive 0.7. Between these two values. Okay, first for Z of minus 1.08. 1.08. Here.
Professor, I have a quick question. If we're gonna have questions on the quiz that require this table, is that table gonna be provided for us, or should we download like a PDF? have
you
that
can
handy.
prepare your own table. You can put it on the, put it either print it, okay, or you can put it on one of your screen. So get them ready. So during the quiz and the exam, okay, to save.
Okay, thank you.
For that value is 0.1401. Okay, and for 0.7, remember that's positive. 0.7 is here. Okay, so that is 0.7. Okay, so 0.7580 minus 0.1401 is the answer. Okay. And for part D, so part D is asking outside Z of 0.96 and Z of 1.62. Okay. So outside is two values, is here and here. Okay. So what we're gonna do is first for 0.96, okay, this part is A315.0. Okay, and then for this part, look at Z of 1.62. 1.62 is here. Okay, so that is 0.9474, correct? Remember, you should use 1 minus.
Logo from UAB. 94. Give Donald.
Okay, so
That's all I needed. That was the edit. All right, fellas.
okay. All right, so that part is 1 minus 0.9474. Okay, so the areas outside this should be this part plus that part. Okay, so you get the idea. So when you use the Z table, depending on what the question is asking, either on the left-hand tile, right-hand tile, anywhere in between, or sometimes even outside a certain area. Okay, just several tricks. Okay, so make sure you follow what the question is asking. So it's very basic to use table upon two to look at the probability. Okay, make yourself very familiar with this procedure. The next question is question number 4. Let's go back to the question. Question number 4 is here. So give X is follow a normal distribution n to 9. Okay. So asking this, so A for P X larger than equal to 2. Okay. So B between 1 to 7. Okay. C also between two values. Okay. D again. Okay, so how to answer this question? Again, we use table upon two. But before we do that, we need to calculate the z-value. Okay. The z-value can be calculated based on the equation. Okay. So z is equal to x minus mu, okay, over sigma. Okay. So here, for the normal distribution, mu is 2. That's mu. Okay. What is sigma? Okay. So sigma is this. So sigma squared is 9. So sigma is square root of 9. So that's 7, that's 3. Okay. So mu is equal to 2. All right. So the remaining will be the same as the previous question. Ask for x larger than 2. Okay. So we calculate the z-value for part A. So z-value x is 2, okay, mu is 2, sigma is 3. So z-value is 0. Right? Then for 0 normal distribution, the z-value will be 0, as you can see from here. Okay. The z-value is 0. And the area to the right of z is 0.5, 50%. Okay, because the z curve is symmetrical to 0, 0. Okay, so the areas to the right of z is 0.5. So p for x larger or equal to 2 is equal to 0.5. Okay. Another thing I should mention is the equality line here doesn't really matter. Okay. So that means px larger or equal to 2 will be the same p as for x larger than 2. Okay. So if whether we have equal or not doesn't really help. So for continuous distribution, the endpoints does not count, doesn't matter. Okay, over that. Right. For B, again, we calculate the two values based on this equation. Right. So I just show you one of them. So z for x equal to 1, so 1 minus 2 over 3. Okay. And for the next is 7 minus 2 over 3. Okay. So that will transfer for p-value between z-score of minus 33 and 1.67. Okay, so in the areas between, we should use what we just calculate, something like this. Okay, so we'll find the value on the left-hand tail of the larger z-value minus the areas we found out for the smaller z-value. Okay, to save us time, I will not do the same details again. Okay, so as long as you transfer into from x to z value, the remaining will be look at the table upon 2 and do the same procedure depending on what the question is asking. Okay. And for C, C is part C is the same. Okay, so we transfer the x, 2x into 2z value, and then we look at the areas between these two z values from the table upon 2. Okay, so again, I will skip the details for C to save us some time. For D, so D is for x between these two. Okay, so we should simplify this. So every part plus 2 will be minus 5, and no minus 5, plus 2 minus 1. to 5. Okay, and then you transfer to 2 z-values, okay, based on this equation. Okay, and then you will do the same thing. Right? So any question about this? Okay, yeah, I think it's pretty straightforward for now. We have done a lot of similar problems already. So that is question number 4. Next is question number 6. Is it here? Oh, sorry, it's not here. 4.5 is here. Flood warning. Okay. All right, question number 6 is here. Sorry. Right. So the depth of piece on a corroded steel surface, so that's one type of corrosion of steel, okay, are normally distributed with mean value 822 μm is micrometer, standard deviation of 29 micrometer. Okay. First part is find the 10th percentile of pit depths. Okay. So again, we're going to use the Z table. The 10th percentile of pit depths, okay, from this information and the Z table, we can find out the Z score for that. Okay. Let me just copy so we can avoid go back and forth. First one is 10th percentile. Okay. For the B is 780 micrometer depth, asking what is the percentile. Okay. And part C is what proportion of pit has depth between 800 and 830 micrometer. So between these two values. Okay. So the idea is the same, but a little bit different between from the first two questions. Let's go to the Z table once again. So the first part A, is asking for the 10th percentile. So what we need to do is we look at the values corresponding to 0.1, which is 10%. Okay, so where it is around here. Okay, so 0.1003, close enough to 10th percentile. So that's corresponding to Z value of what? Minus 1.28. Correct? So that is Z value for 10th percentile. All right. And remember, the Z value is x minus mu over sigma. Okay. The question tells us it follow a normal distribution. Mu is 822 and sigma is 29. So So the variance is 29 squared. Okay, so for z value of 100 minus 1.28, so that is equal to x minus mu. Mu is 822 divided by sigma. Sigma is 29. Okay, so from there we can get x. 784.88. Okay, so the same idea here, based on the percentile, we found the z value, and then we back calculate the x. It's part A. Part B tells us about x is 780 micrometer. Okay, so from there we calculate the z value. So x is 780 minus mu 822 sigma 29. So z value is minus 1.45. Okay, so minus 1.45 is where is here. Okay, so 0.0735. So the areas to the left of minus 1.45, so that area is 0.0735. Okay, so for the depth of 780 micrometer, that is about 7th percentile. Okay, so about 7%. So about 7th percentile. Okay, sorry. Right, so we use the same equation. Okay, depending on what the question is asked, what the question tells us, sometimes tells us the percentile. So from there we get a z-score, and then we can calculate x. Sometimes tell us about x, we can calculate z-score, and then we calculate probability. Okay, same idea. And C, okay, I will not go into the detail. So for C, it's between 800 and 830 micrometer. So what do we do? Okay, so for 800, we calculate the z value for 800. And then the z for 830. Okay, so we get 2 z-score. Okay, the question is asking the areas in between. Okay, so let's say this is z1, z2. Okay, and then from table 8.2, for the larger z-score, the z2, we found out these areas on left-hand tail. Then minus the areas on the left-hand tail of z1, which is these areas. So this minus that will be the areas in between, which is here. Okay, so same trick. That is question number 6. Question number 8. All right, question number 8 is here. So weight of female cats of a certain breed normally distributed. Okay, mean value 4.1 kilogram, standard deviation 0.6. Okay. So what proportion? That's part A. Okay, so part A is what proportion of female cats had weight between 3.7 and 4.4? Okay, first of all, let's write down what distribution it follows. It's follow normal distribution with mean value 4.1, standard deviation 0.6. So 0.6 square. Don't forget that's square, because variance is the square of standard deviation sigma. Okay, so that is that. Okay, so that's mu sigma square. Okay. For part A, between 3.7 and 4.4. Okay. Right now, probably you already know what do we do? We calculate the z-score from x. Okay. For 3.7, so 3.7 minus mean 4.1 over sigma. Okay. So that is z-score of minus 0.67. Okay. And then for the next, z is equal to 4.4 minus mean over sigma. Okay, so 0.5. All right. So between these two values, okay, so that's between minus 0.68 and 0.5. Okay, go to 8.2, table 8.2, you find out areas here. Okay, so I will skip the details. It's part A. Part B, what a certain female cat has a weight that is 0.5 standard deviation above the mean. Okay, so what proportion of female cats are heavier than this one? Okay. So what does that mean when it says 0.5 standard deviation above the mean? Okay, remember what z-score tells us. Z-score tells us how many standard deviation it is far away from the mean value. Okay, if it's a positive value, for example, positive 2, that means it is 2 standard deviation on the right of the mean. Okay, so this tells us how many standard deviation away from the mean value. So question tells us 0.5 standard deviation above the mean. So that tells us the z value is equal to what? Anybody want to guess? The z-score for that is what? (0.5). Okay, so 0.5 standard deviation above the mean. So the z-score is positive 0.5. Okay, and then we use the table 8.2. Okay, 0.5. All right, and don't forget the table 8.2 tells us the left-hand tail. Okay, so from table 8.2 we found out this area corresponding to the z value of 0.5 is let me find out. Okay. It is 0.6905. Okay, and the question is asking percentage of female cat heavier than this one. So it's asking actually these areas instead. So we should use 1 minus the value we found from the table. Okay, so that is 0.3085. So we have 30.85% of the cat are heavier than this one. Okay, again, the z-score tells us how many standard deviation away from the mean. Okay, positive z-value means on the right hand, more than the mean. Negative z-value means less than the mean. Okay. So question about part B. Then part C. Okay. So part C is asking how heavy is a female cat whose weight is on the 80th percentile. Okay. So what do we do on that? So 80th percentile, we go to table 8.2, find the value close to 0.8000, the closest one. Okay. So find the z-score close to 0.88. Okay. Again, we will save the effort to go back to table 8.2. From that, we can find the z-score. It is around 0.84. Okay. Then asking for the weight. How heavy? Okay. So the weight x will be 4.1. Okay, why is 4.1? Because x will be equal to mean plus z times sigma. Okay, again, this is because z is equal to x minus mu over sigma. Okay, so based on the same thing. So we get a z-score, which is 2.84, and the mean value 4.1, and sigma 2.6. So we calculate the weight of the female cat, which is 4.6. That's part C. Part D. All right. So a female cat is chosen at random. What is the probability that she weighs more than 4.5 kilogram? Okay. Again, we calculate the z-score for 4.5 minus x divided by sigma. So z-score 3.67. Okay. The question says heavier than 4.5. So heavier means on the right-hand tail, correct? But again, don't forget, table 8.2 only tells us about the left-hand tail. So the value corresponding to 2.67 z-score is this area. Okay, so we should use 1 minus this area to get what the question asking here. Okay, so which is 0.2514. Okay, again, go back to do the question yourself, see if you can get the same answer. So do the practice by yourself. Okay. So that's the answer. Okay. So 25% of female cats heavier than 4.5, or the probability is 25% heavier than 4.5 kilogram. Part E is a little more interesting. Okay. So 6 female cats are chosen at random. What is the probability that exactly one of them weighs more than 4.5 kilogram? Okay, so from the previous part, part D, we know a random chosen female cat heavier than 4.5 kilogram is this much. Okay, so 25%. Okay, more than 4.5 kilogram. Okay. And in part E, we choose 6 cats at random, okay, asking exactly one of them with more than 4.5. Okay. So what type of distribution we should use to describe this experiment? Okay. Remember, we only discuss 4 total distribution. So Bernoulli, binomial, Poisson, and then normal distribution. Okay. So this question is similar to we toast the die n times, because each toast is, we can think as a Bernoulli distribution, because the success rate for each toast is the same. Okay. For this experiment, we pick 6 cats, and for each pick, the probability of the cat heavier than 4.5 is the same, 2.25, 25% heavier than 4.5 kilogram. Okay. So this experiment is actually follow a binomial distribution, NP. Okay, and N here is 6, P is 0.2514. Okay. After that, things will be easy. For binomial distribution, you have the PDF, probability density function. Okay. And Tuesday this week, we have the practice question on the binomial distribution. Okay, so that is PDF. So that's this part. So asking exactly one of them with more than 4.8. So that's asking p x equal to 1. Okay, so what we do is we plug x equal to 1 here, n equal to 6 here, and p is equal to 0.25 here. And then plug in the equation, we calculate the px equal to 1 is 0.35146. Okay, again, you can use your calculator to do the calculation itself. Okay, probably you can just tell the calculator, it follow binomial 6, 0.2514. Calculate px equal to 1. Okay. So that's part E. Question number 8. Question or comments on this question before we continue? Then page 300, question number 2. Question number 2 here. So we have 500-page book contains 250 sheets of paper. The thickness of the paper has a mean value and standard deviation. So this value are known. A, what is the probability a random chosen book is more than 20.2 millimeter thick, not including covers? Okay. From section 4.11, which is central limit theorem, or CLT, okay, tells us under certain conditions we can use normal distribution to describe a certain experiment. And one of these conditions is the sum. Okay, the sum of n item added together, okay, it follow a normal distribution, which is equal to n mu and n sigma square. Okay, so no matter what type of distribution it follows, okay, if n is large enough. Okay, so first of all, let's define, okay, x1, x250, because we have 250 sheets of paper for the whole book. So that is the thickness of these 250 sheets. Okay. And the total thickness of the paper is equal to the thickness of the book. Okay, so let's define S equal to x plus x1 plus x2 plus x250. Okay, so that's the total thickness of the book. We call that S. Okay, so S will follow a normal distribution because, again, this is one of the conditions for central limit theory. Okay, so S follow a normal distribution. So N, so N mu and N sigma square. Okay, and here N is 250. Okay, mu is for each paper, the mean thickness is 0.08. Okay, and sigma is the 0.01. Okay, 0.01 for sigma. Okay, so from there, we know S, or the total thickness of the book, follow a normal distribution of this. Square. Okay. Then what are we gonna do? We use the Z table. Okay. A, probability that random chosen book is more than 20.2. Okay, so more than 20.2. Okay, so we calculate the score, the Z score. So 20.2 minus mu, which is 20, divided by standard deviation. Okay, so the Z score for 20.2 is 1.26. Okay, so you can do the procedure yourself, see if you can find the same thing. And then the areas to the right of Z of 1.26, okay, because the question is asking more than 20.2. More than 20.2 is on the right, right? So don't forget that part. Okay, so area to right of that Z value, okay, is 1 minus 0.8962. Okay, so that value is what you found from the Z table. Okay, okay, so that is the probability. So the probability, the thickness of a book larger than 20.2 is 10.38%. Part B, what is 10th percentile of the book thickness? Okay, easy. Okay, we have done that before. After we figure out the distribution and the parameters for that, the mu and the sigma, remaining will be the same. So 10th percentile, what we do is we go to table 8.2, okay, looking for the Z value corresponding to 10% or 0.1. Okay, so find that Z value. Table 8.2 first. from z value minus 1.28. Minus 1.28. Okay, but that basically means here, for the z value of minus 1.28, that area is 10%. Okay. So the next z value is equal to x minus mu over sigma. Okay, so we get x. So the x is this much. Okay. Part C is a concept question. Someone want to know the probability that a random chosen page, so one random chosen page is more than 0.1 millimeter thick. Is enough information given to compute this probability? The answer is no, okay? Because we do not know what type of distribution one single page thickness follows. The question didn't tell us about this, okay? Why we can use normal distribution, though? That is because in part A and B, we care about the total thickness, the thickness of 250 pages, okay? So that follow normal distribution. However, for a single page, we do not know what type of distribution it follows. And because of that, we do not know whether the page thickness is normally distributed or not. Okay, so not enough information to calculate this probability. Okay, the answer is no. All right, so we have two more questions. Let's just hurry up. Question number 4 and 6 is the last two questions. So central limit theorem is a little bit more complicated, okay, because we need to transfer other type of distribution to normal distribution, okay, and sometimes we need to do a so-called continuity correction. Okay, so that's more steps. So among all monthly bill from a certain credit card company, the mean amount billed is 485. Standard deviation is 300. And for 50% of the bill, the amount billed was greater than 1,000. Okay, we have a sample of 900 bill. Okay, so first, let's define x1, x900 is the amount for this 900 bill. Amount. Okay, so part A is asking the probability the average amount of bill on the sample bills is greater than 500. Okay, so we have 900, so much more than 30. So when the sample size is enough, larger than 30, the mean value follow a normal distribution. Okay, mu sigma squared over n. Okay, because the question is asking the average, so average is the mean. Okay, so the mean value follow normal distribution. Okay, with a mean value of mu. Okay, mu is 485, doesn't change. And the new variance is based on this. Okay, so sigma here is 900, 300. So 300 squared over n is 900. Okay. All right, so follow a normal distribution. So the mean will be 485, doesn't change. Okay, but the variance will be 100. So the sigma is 10. Okay, so that's mu, that is sigma squared. All right, so after we figure that out, then we use the table, the Z table. Okay. Greater than 500, calculate Z score. 500 minus mu, 485, over sigma. Sigma is 10. Okay, Z score is 1.5. All right, so we need to calculate the area to the right of Z. Okay, because the question is asking more than 500. So right of Z of 1.5 will be 1 minus 3.9332. Okay, so that value is what we found from the table 8.2. Okay. Okay, see if you can get this. B, okay, what is the probability that more than 150 of the sampled bill are for amount greater than 1,000? Okay, so let's define Y. So Y is the number of bill whose amount is more than 1,000. Okay. Number of bills more than $1,000. Okay. The question tells us, the second sentence, for 15% of the bill, the amount of bill is more than 1,000. Okay, and totally we have 900 bill. Okay, this is again a binomial distribution. Okay, we have 900 trial, and for each trial, the success rate is 15%, because the question is asking how many bills more than 1,000. Okay, so Y actually follow binomial 900 0.15. Okay, so that's a binomial distribution question. Under certain conditions, we can use normal distribution to describe binomial distribution. Okay, so Y is approximately normal. Okay, so with the mean value and standard deviation. But before we do that, let me write down the condition. So if X follow binomial NP, okay, and NP larger than 10, and N times 1 minus P also larger than 10. So if these two conditions met, then X can also be seen as follow a normal distribution of NP and NP times 1 minus P. Okay, so that's the normal distribution. And right now, we know it follow a binomial distribution, okay, NP. And N is 900, P is 0.15. Okay, and then we need to check NP if it's larger than 10, and N times 1 minus P larger than 10. If so, we can use normal distribution to describe that. So we calculate NP and n times 1 minus p. So both of them larger than 10. So y is approximately normal distribution, follow a mean value. Mean value will be equal to NP, okay, 900 times P, 0.15, so 135. And standard deviation is square root of NP times 1 minus P. Okay. Standard deviation is 10.712. Okay, so X will follow normal distribution of 135 and square of 10.712. Okay, so that's the normal distribution we should use. Okay, so you may wonder, we know it followed by normal distribution, why we can't just directly calculate the probability? The answer is it's very hard, next to impossible. Okay, so for example, if you use binomial distribution, how we can calculate the probability that more than 150 sample bill? Okay, we should calculate, px equal to 151 plus px equal to 152 plus blah 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 plus p equal to x equal to 900. Okay, it is super hard to calculate because this is the discrete distribution. We need to add all the probability together. But if we can transfer that into normal distribution, we can just easily use the theta table to calculate the probability. And that's why we use central limit theorem to calculate that. Okay, so now we know it is follow a normal distribution. Okay, the question asking p x larger than, we call that y now. Okay, so y larger than 150. Okay. So one more thing is called continuity correction. Okay, so you may forget what does that mean. Okay, so that means when we transfer discrete variables to continuous variables, okay, we need to care about the endpoints. So the question asking larger than 150. Okay, so 150 doesn't count because we don't have equal to 150. So when we transfer the binomial, which is discrete variables, to continuous, which is to normal, which is continuous variables, okay, we need to shrink the range a little bit. Okay, how to shrink the range? Okay, so we need to increase 150 to 150.5. Okay, so by doing that, we shrink the range a little bit, and that is called continuity correction. Again, that is because we're asking y larger than 150. So 150 doesn't count. So we need to shrink the range. Okay, so we need to find the z-score of 150.5. Okay, so z-score for 155. So 150.5 minus x over sigma, so 1.245. Okay, and area to the right of z 1.45, okay, is 1 minus 0.9265, okay, because it's asking to the right, okay, and 0.9265 is from table 8.2, which always tells us to the left-hand tail, so 1 minus that, okay, 0.0735, okay, so that's probability. So 7.35%. More than 150 of the bill greater than $1,000. Okay, so this part B for question number 4 is a little tricky. Okay, because first of all, we need to figure out if follow a binomial distribution, and then we use central limit theorem to transfer that to a normal distribution. Okay, and then finally we use continuity correction to do the little adjustment. Okay, I will say probably this is the most complicated questions for chapter 4. Okay, so go back to digest the information here. All right, we have one last question. We only have 7 minutes, but I will try to finish that. I will finish that because next week is the spring break, and if you have to go, you can go for the next class. I will finish last questions before we dismiss. Okay. So question number 6. So the amount of warpage in a type of wafer used in the manufacturing of integrated circuits. Okay, so I don't even know what does that really mean. Here, the mean value 1.3, standard deviation 0.1. Okay, we have random sample of 200 waffle is drawn. A, what is probability that the sample mean exceed 1.305 millimeter? Okay, again, when the sample size is large enough, the sample mean will follow normal distribution. No matter the single item follow what type of distribution, doesn't matter. The mean follow normal distribution of this. Okay. So let's define x1, x200 is amount of warpage. Okay. In 200 wafers. Okay. And then the mean value of these 200 waffles follow a normal distribution. Okay. So the mean value of mean, sample mean, is mu. Mu tells us 1.3. Okay. And the standard deviation of the 200 sample mean is 2.1 over square root of n, which is 200. Okay. So that is 0.00707107. Okay. All right. So that's the mean value and the sigma. So x follow normal distribution of 1.3 and 0.00707707 squared. Okay. After that, probability exceed 1.305. Okay. The z-score for 1.305, okay, we use the equation x 1.305 minus mean 1.3 over sigma. So the z-score is 0.71. All right. So the question is asking exceed 1.305, so more than 1.305. So the area should be the right of Z. To right of Z of 0.71 is 1 minus 0.7611. Okay, again, this is from the table 8.2. Okay, so that is answer 23.89%. Part B, find the 25th percentile of the sample mean. Okay, again, same idea. 25th percentile, let's call that x25. So the z-score for the 25th percentile is minus 0.67. Okay, how to do that? Go to table 8.2, look at for the z-score corresponding to 0.2500. So the closest you can find, that's the z-score. So that is minus 0.67. Okay, so based on the equation, okay, so z is 2.67, mu 1.3, sigma okay, so we get x. So x, 25th percentile is, okay, so make sure you can go back and see if you can have the same answer. Okay. The last part of the question asking how many waffles must be sampled so that the probability is 0.05 that the sample mean exceed 0.135. Okay, it is asking what is the sample size. Okay, the sample size is shown here. Okay, shown here. So n is the sample size, and we know x, the mean value follow a normal distribution. Okay, the mean value of the average is still 1.3, and the standard deviation is 0.1 square root of n. Okay, because the equation here. Okay, and the question tells us the probability for the mean value larger than 1.305 is 5%. Okay, and based on table 8.2, we can find out the z-score. Okay, the z-score corresponding to 95th percentile. Okay, so only 5% larger than that value. So that is 95th percentile. So the z-score from the table 8.2 you should find is this 1.305. Okay, 1.305 is the 95th percentage of the distribution of x. Sorry, that's not the z-score. Okay, so 1.305 is the 95th percentile of the mean value of x. Okay, and the z-score we found based on table 8.2 is equal to 1.645. 1.645. And then okay, we use the equation x equal to z sigma plus mu. Okay, and x is 1.305. Okay. Z is 1.645. And sigma is the value with sample size n, and mean value is 1.3 here. Right. So this equation is the same as the z-score. Okay, so basically the same. Z is equal to x minus mu over sigma. Okay, so using this equation, the only unknown is sample size n. Okay, from here, n we can calculate is around 1083. Okay, so the answer is at least 1083 waffles must be sampled that the probability is 0.5%, 0.05 that the sample mean exceed 1.305. Okay, from here you can see we use the same equation. Depending on what the question is asked, we can calculate backwards or forwards, and yeah, the idea will be the same. The only thing more complicated, I think, is the central limit theorem. That is depending on the situation, we can use normal distribution to calculate either the mean value or the sum of the items. Okay, so that's the last question for chapter 4, practice question. Okay, questions?